Okay, so we're going to find the inverse of A. This is the same matrix as the Gaussian elimination. Now we're going to use the other technique. It's a bit longer, but it gets the same result. Okay, so first we need to think of the inverse of A is the adjoint of A over the determinant of A. So the adjugated A is the transpose of the cofactor matrix. We will get to that shortly. Let's work out what the determinant of A is first. So we're going to say determinant of A is, there's no real shortcut here. Let's just expand row 1, 2. And the leftover matrix is 2, 1, 1, 2, 2, 1, 1, 2, minus 1, 3, 1, 1, 2, 3, 1, 3, 1, 2, 2. Very easy to make a mistake. 1, 3, 2, 2, 1. Okay. 2. AD minus BC, 2 2s are 4, minus 1, minus 1. 2 3s are 6, minus 2. 3 1s are 3, minus 4. 2 times 3 minus 1 times 4 plus 1 times 6 minus 4 minus 1 equals 1. So we can now say that the determinant is 1. Okay. Adjoint A. Okay. So the first thing we need to find is the cofactor matrix. Cofactor matrix. Let's get us some room here. Okay. So instead of writing the 2, we're going to cover up row 1 and column 1, which the 2 is in, and that's our leftover numbers, and that goes into the determinant. 2, 1, 1, 2. The next one, we're going to cross out where the 1 is, and the leftover is 3, 1, 2, 2. 3, 1, 2, 2, and so forth. 3, 2, 2, 1. And we're going to keep going without making a mistake. Easier said than done. You'll notice I'm not concerned about where the negatives are just yet. And row 1, column 1, 1 plus 1 is 2, even, so that's positive. Row 1, column 2, 1 plus 2 is 3, odd, so that's negative. Row 1, column 3, 1 plus 3 is 4, that's even, so that's positive. Row 2, column 1, 2 and 1 is 3, you can see the pattern there. Okay. So our cofactor matrix becomes AD minus BC, so it's going to be 4 minus 1, the negative of 6 minus 2, and 3 minus 4. The negative of 2 minus 1, 4 minus 2, the negative of 2 minus 2, 1 minus 2, the negative of 2 minus 3, and 2 2s are 4 minus 3. And let's get some room here. 3 minus 4 minus 1 minus 1, 2, 0, minus 1, 1, 1. Minus 4, sorry, 3 minus 4 minus 1, minus 1, 2, 0, and minus 1, 1, 1 becomes our cofactor matrix. But we're wanting a joint A. So we've got to take that cofactor matrix and we need to transpose it. So remember, a joint A is the transpose of the cofactor matrix. So we leave our leading diagonal exactly the same. 3, 2, 1. This -1 and -4 change places. The two negative ones change places, and the 1 and the 0 change place. That becomes our transpose of our cofactor matrix, which is a joint A. Now that we have a joint A over the determinant, remember our determinant's 1, so that becomes an inverse matrix. I cheated a little bit because when we divide by 1 we don't change, so that becomes our inverse matrix, and hopefully that agrees with what we got with Gaussian elimination. I'm sure it does, and that's the process, the long-handed process of getting the inverse matrix. Please note that you're not always going to get a determinant of 1, so yes, you're going to have some fractions in there, but it's all good fun, isn't it?